Okay, the rule is you can't have a square root, you can't have a square root in your denominator. And if you remember, I equals the square root of -1. Okay, and technically we have a square root down there. So we got to get rid of it. So the way we're going to get rid of it is we're going to multiply it by something called the conjugate. And what the conjugate is the same terms. So 3 and I are the same, and it's going to be the same on the top as it is on the bottom, because in essence we're multiplying by 1, and this is our 1. Okay, but we have the same terms, but we're going to switch signs. Okay, and so then what that works out to be is on the top it's 1 plus 2i times 3 plus I. And then on the bottom, we have 3 minus I times 3 plus I. And if you remember the difference of squares pattern, you'll see how this works out. But I'm going to continue doing it just in case you don't remember what the difference of squares pattern. Remember the difference of squares pattern was called a conjugate pattern by Newton, and this is kind of why. Okay, so because we call this the conjugate, that is called the conjugate. Okay, so now what I'm going to do is I'm going to multiply my binomials. So I don't necessarily use FOIL. I use a method that's just as organized, but it's not exactly the same. So I'm going to distribute my 1 to my 3. That's going to give me 3. I'm going to multiply my 1 times my I. That's going to give me just plain old I. And 2i times 3 is going to give me 6i. And then 2i times I is going to give me plus 2i squared. Okay. And then on the bottom, I'm going to have 3 times 3, which is 9. 3 times I, which becomes 3i, positive. A negative I times 3 gives me a negative 3i. And then negative I times I gives me a negative I squared. And now we're going to work through, we're going to start with terms. So the 3 is going to stay the same for the minute. And then I plus 6i is going to become 7i. And then 2i squared is going to become 2 times -1. Because remember, I squared equals -1. Okay. So that's why I'm substituting that in for I squared here. Okay, so, and then on the bottom, we have 9. Our 3i and our minus 3i cancel out. So we're like 9 minus I squared. And remember, that's a -1. Okay, now I'm going to come down here and I'm going to rewrite what I have up there. So just so there's no confusion. So 3 plus 7i plus 2 times -1 on the top. And then on the bottom, we have 9 minus a -1. Okay, so now we're going to work those through. So we have 3 plus 7i minus 2 over 9 plus 1. Notice our negatives canceled out here, and this becomes a -2 when you multiply it. So we're going to do like terms, 3 and -2. So that's going to give us just a 1 plus the 7i we can't do anything with. Okay, it's like this is an apple, that's an orange. You can't combine them unless you're making fruit salad, and we're not doing that today. But we do have 2 apples down here, so 9 plus 1 gives us 10. So that's our final answer. 1 plus 7i over 10. Notice we got rid of the I squared because we wound up using the difference of squares pattern to form 9 minus I squared. When I squared became -1, we totally got rid of it. Okay, while this is correct answer, 1 plus I equals 10 is correct, we would like you to continue to go one more step, and that is to write it like this. Put each item, each term, like 1 over 10 plus 7i over 10. That way it's written out and it is complete. And that'll be how you would write that for Newton as well. Okay, so let's do this way. Instead of having that. Okay, so while this is correct, we're going to write this in a different way so that it's called standard form. So what we're going to do is we're going to take our 1 and put it over 10. We're going to have our plus, and we're going to put our 7 over 10, and we're going to put our I afterwards, as it's not part of the fraction at all. 7/10 is the coefficient for I. So this would be the proper form of A plus BI.